heart is supplied with arterial blood by the branches of the right and left coronary arteries. The right coronary artery, or RCA, supplies the right ventricle through a marginal branch which arises near the origin of the vessel. In 90% of individuals, the RCA then goes on to supply the inferior surface of the ventricles through a branch called the posterior descending artery. This posterior descending branch also supplies the posterior 1/3 of the interventricular septum. Blockage of the RCA distal to the origin of the marginal branch infarcts the inferior surface of the heart. This inferior surface is examined by leads 2, 3 and AVF. In inferior infarction, the injury current, represented here by the blue arrows, therefore produces ST elevation in these leads. Note also that the injury current is moving directly away from leads 1 and AVL. As we'll see shortly, on the ECG this can produce ST depression in these leads, so-called reciprocal change. On a standard ECG, the recordings from leads 2, 3 and AVF are grouped together in the bottom right-hand corner of the A4 readout. This ECG demonstrates the classical pattern of inferior ST elevation MI, with ST elevation in leads 2, 3 and AVF, and reciprocal ST depression in leads 1 and AVL. In this example, reciprocal change in leads 1 and AVL does not indicate disease in the region under these leads. It is purely an electrical phenomenon produced by injury current in the inferior region. As the inferior surface of the heart is supplied by the RCA in 90% of people, this ECG pattern usually indicates obstruction of that artery. Blockage of the right coronary artery proximal to the origin of the marginal branch will result not only in infarction of the inferior surface of the ventricles, with ST elevation in leads 2, 3 and AVF, but also in extensive infarction of the anterior wall of the right ventricle. You'll notice that the ECG in this situation is virtually identical to that observed with distal RCA obstruction. In fact, the standard 12-lead ECG gives very little information about the free or anterior wall of the right ventricle. Even leads V1 and V2, which face this surface of the ventricle, are dominated by signal from the septum and may show little or no change in the presence of significant RV infarction. Determining the presence or absence of extensive right ventricular involvement in ST elevation MI is challenging, but is of great clinical importance. For those interested, we will discuss the diagnosis of ST elevation MI in ECG blind regions of the heart in the quiz section. The left coronary artery divides into two major branches: the left anterior descending artery and the left circumflex artery. The left anterior descending artery, or LAD, generally supplies the anterior surface of the ventricles and the anterior 2/3 of the interventricular septum through septal branches. Diagonal branches of the LAD supply a variable extent of the anterior and, in some individuals, lateral surface of the left ventricle. The septum is examined by leads V1 and V2, while the anterior surface of the left ventricle is examined by leads V3 and V4. Proximal obstruction of the LAD will be associated with ST elevation in these leads and anterior MI. Again, the inferior leads are viewing the injury current from a diametrically opposite position and may show reciprocal ST depression. This is the classic ECG pattern for an anterior MI secondary to LAD obstruction. The left circumflex artery supplies the posterior and high lateral wall of the left ventricle. So the changes of infarction in the territory of this vessel are prominent in those leads looking at the left lateral surface of the heart. That is, lead 1, AVL, V5 and V6. Changes of ST elevation MI in these ECG leads are often subtle and are easily missed. Of course, there are many variations on the basic correlations outlined here, depending on the variation in coronary artery anatomy between individuals and the impact of collateral formation in patients with a long history of ischemic heart disease. To give you one of many examples of the former, in 10% of individuals, the posterior descending branch supplying the inferior surface of the heart arises from the left circumflex artery rather than the right coronary artery. This is termed a left dominant coronary circulation. In such an individual, an inferior pattern of ST elevation indicates obstruction of the left circumflex. Equally, proximal obstruction of the circumflex in such an individual will produce ST elevation in both the inferior and lateral leads, and infralateral MI. The point is, in ST elevation MI, the leads in which ST elevation is present gives you a good guide to the anatomical location and extent of the infarction. The artery responsible for infarction of the territory affected can usually be inferred, but there are well recognized variations in supply between individuals.